This video is Chapter 4, the Chapter 4 part of the review. Number 1 should be a pretty good one to start us off. We're just looking for a y-intercept here. So we've got f of x equals negative, and then in parentheses, x plus 1 quantity squared. So remember the way y-intercepts work, it doesn't matter what kind of function you're dealing with, you find the y-intercept the same way. So all we're going to do is we're going to plug in 0 for x and then solve for y. And remember, this is always y anytime you see an f of x. I'm just going to replace it right now so it doesn't freak us out. So negative, and then in parentheses, we plug in a 0 for x. That's how we always find our y-intercepts. And then we can simplify this up. So 0 plus 1 is 1. We square it, we get 1. Then we make it negative. And so this ends up being a negative 1. Be careful with that. The negative on the outside means our answer does end up negative at the end. And so that is letter B. Number 2, equation of the axis of symmetry for this graph right here. Okay, so this form that our graph is in, this is called vertex form. When you're in vertex form, do not FOIL, do not simplify anything up. When you're in vertex form, your vertex is given to you right away. So the vertex, the way the formula works is this. The x value is the opposite of what you see right here, so negative 6. And then the y value is exactly what you see right here. What I've told you guys in class before is that x lies. So x shows the opposite, and then y shows the same. The vertex always lies right on the axis of symmetry. So that means the axis of symmetry is the vertical line x equals negative 6. That value right there. That is letter G. Okay, the graph of, let me write down this equation. It's kind of like a fill in the blank one here. Negative 2x squared plus x opens, and it would be down. This negative right here tells you that it's going to open down like that. If it opens down, the value that it has is a maximum. So it opens down and it has a maximum. It's letter A. If this value were positive, then it would open up, and if it opens up, then it has a minimum. Okay, the related graph. Here we go. So we're going to have to look at the picture for this one for sure. So the related graph of a quadratic equation is shown at the right. Use the graph to determine the solutions of the equation. All right, so the solutions are the x-intercepts. So the x-intercepts, we've got one right here. That would be 2. So that leaves these 2 as options. And then right here, it crosses the x-axis at negative 3. So when they're asking for solutions, that's the same as asking for roots, is the same as asking for zeros or for x-intercepts. We've got so many different synonyms that we've used for this thing. So positive 2 right here, and then negative 3 right here, and that would be letter H. Okay, quadratic function x squared. This is an interesting question. Okay, so let me show you the options that we're dealing with here. X squared has no zeros, exactly 1 0, exactly 2 zeros, or more than 2 zeros. First of all, this one's out. You can't possibly have more than 2 zeros because our degree is only 2. So x squared, what we want to do is we want to see when x squared is going to be equal to 0. And this is actually a pretty easy equation to solve. You just take the square root of both sides to get x by itself. So x equals, now normally you would do a plus or minus here because you're taking a square root, but positive 0 and negative 0, first of all, there really isn't such a thing. 0 is just 0. So the only solution we get is x equals 0, and so that would be B, exactly 1 0. Okay, solve by factoring. So one thing I want to emphasize to you guys is the difference between just factoring something and solving by factoring. So for solving by factoring, in the end we should have like x equals something else. If you're just factoring, all you do is you leave the factors and you couldn't solve even if you wanted to. You have to have an equation in order to solve. So we start off with our factors. Equals 0. Since this leading term is an x squared, whatever I multiply here and here has to give me x squared. So really my only option is x times x. And then these two numbers, they're supposed to multiply to negative 10, but I have to make sure that when I do the FOILing, I end up with a negative 3 in the middle. So I'm trying to find two numbers that multiply to negative 10 and add to negative 3. And that would be negative 5 and positive 2. You can always refoil, multiply this whole thing back out, make sure you end up with this trinomial, which I promise you will. To solve by factoring, you take each factor and you set them individually equal to 0. Okay, so this one on the left, we're just going to add 5 to both sides. So we get x equals 5. And then here we're going to subtract 2. So we get x equals -2. So now, because your review is multiple choice, it's probably pretty easy to just kind of plug answers in and see if they work. However, watching the video will hopefully show you exactly how you would do the process if you did not have a multiple choice, which remember, you will not on your test. All right, so this matches with H, 5 and -2. Which quadratic equation has roots -2 and 3? So our roots are -2 and 3. So we're going to kind of work our way backwards, and I'm really glad this one is on the screen. So if you have a root of 5, that means you have a factor of x minus 5. If you have a root of -2, that means you have a factor of x plus 2. So let's go and look at this one. If we have a root of -2, that means we have a factor of x plus 2. And if you have a root of x or of 3, that means you have a factor of x minus 3. It's like the exact opposite process of what we were doing right here. So then we would take those factors and put them into an equation. So we've got the factor x plus 2, we've got the factor x minus 3. We set it up just like we've got up here. We set it equal to 0. So we're literally working backwards through these steps. We just went from this step to this step to this step. Now we want to get it here, which means we're going to FOIL. So x times x gives us x squared. X times -3 gives us -3x. 2 times x gives us 2x. And 2 times -3 gives us -6. Don't forget my equal 0 because it's supposed to be an equation. Then I can combine up my middle terms here. So a -3x and a positive 2x. I'm left with a -x in the middle. Okay, so that is my equation, and it looks like we're going with option B. Okay, simplify. Foiling some complex numbers here. Okay, so we're going to multiply these out, just like foiling that we did like right here. So we multiply 5 times 1, and we get 5. 5 times 3i gives us 15i. 2i times 1 gives us 2i. And then 2i times 3i gives us 6, and then I squared. Okay, so 2 things we need to do to simplify. This guy right here, every single time that we come across an I squared, we're dealing with the realm of imaginary numbers. I squared is equal to -1. It's the imaginary number that we purposely defined that way. It's the only possible number that you can square and end up with a negative number. So every single time you replace, or every single time you see this, you replace it with a -1. Okay, so that's what we're going to do first. 5 plus 15i plus 2i, and then plus 6 times -1 instead of an I squared. So I can combine these two. That combines to a positive 17i. Let's come up with my numbers. This is 5. This is a -6. So 5 and -6 gives me -1. All right, so that is my new complex number. All right, and that is letter H. Electricity. We've got the total impedance of a series circuit. We actually saw a really similar story problem to this in the notes. The sum of the impedances of all parts of the circuit. Technician determined the impedance of the first part was 2 plus 5j. Now remember, with this physics stuff, we use j instead of I, but it means the same thing. The impedance of the remaining part was 3 minus 2j ohms. Okay, and then that first sentence is the total impedance is the sum of the impedances of all the parts. All right, so we're just going to take this part and add it to this part. And when you do that, what you're doing is combining like terms. So we just looked at multiplying complex numbers. Now we're going to look at adding them. And it's actually pretty basic. You just combine up the number part and you combine up the imaginary part. So we combine up the 2 plus 3, and that gives us 5. And then we combine up the 5j plus -2j, and that gives us 3j. Okay, and then of course ohms is our unit, and that's letter A. Okay, to solve this equation right here, using the square root property, you would first rewrite the equation as, all right, so first of all, this thing right here is a perfect square trinomial. We've talked about this when we were doing completing the square. The reason that it's such a nice property is because when you go to factor this down, we've got x and x. we want to figure out what multiplies to 16 and adds to 8, and that would be a positive 4 and a positive 4. We love this. We love this pattern, I guess, because when you factor this down, instead of writing it out twice, you can write it like this. And that's why we call it a perfect square trinomial, because we can end up writing it as a perfect square like this. So this is how you'd write it as your first step. And then there are many more steps after that, but the multiple choice was just asking you for that first step. Okay, this one has to do with completing the square as well. So find the value of C that makes this a perfect square. Okay, so the way we find this missing constant right here is we start with this middle number, and we've got a process. First we cut it in half, and then we square it. Okay, so we take 10. First we're going to cut it in half. That gives us 5. And then we're going to take the 5, and we're going to square it. So that gives us 25. So the number that I should put right here that makes this a perfect square trinomial is 25. Okay, I'm going to flip for number 12. Okay, quadratic equation x squared plus 6x equals 1 is to be solved by completing the square. Which equation would be the first step in that solution? So the first step is to do actually what we just did on the previous page. It's to start with that number, cut it in half, and square it. So I start with 6, cut it in half. That gives me 3. Then I'm going to take 3 and square it, and that gives me 9. So what I would do is I know that adding a 9 right here would make this a perfect square trinomial. What I need to do to keep it balanced is I also need to add a 9 to the other side. And so that exact step is laid out in letter J. Okay, number 13, find the exact solutions using the quadratic formula. So we are going to practice the quadratic formula here. First of all, if for some reason your equation is not in perfect standard form before you start the formula, you have to get it into that form. Let me write down the formula so that we have it. This would be an awesome thing to put on note cards, by the way. Unless you have it memorized by the Notre Dame fight song, which I know I do. Okay, so we're going to plug everything in. So every time you see an A, you're going to plug in a 1, because there's technically a 1 right here. Every time you see a B, you're going to plug in a -3. And every time you see a C, you're going to plug in a 1. So as long as that formula is memorized, you should be good to go, and then you're just kind of plugging things in. So x equals -b, that's a -3, which switches it back to positive, plus or minus square root b squared. If I take this and square it, remember you're doing a -3 times a -3, which comes out as a positive 9. And then minus 4 times a is 1, and then c is also 1. Okay, and all of that over 2 times 1 is 2. Let's simplify up that square root. So I have 9, and this is just 4, because it's 1 times 1. So I have a 5 under the square root. And then since 5 isn't a perfect square, I can't take it any farther. And that matches with the last option. This is letter D on our multiple choice. Okay, value of the discriminant. So for questions 14 and 15, let me lay out some info about the discriminant here. So first of all, this is the formula. It is just the part of the quadratic formula that's underneath the square root. All right, so we've got multiple options here. This first one, let's walk through this. So here's our equation. We don't need to solve the whole quadratic formula. We just need to do the discriminant. So b squared is -3 squared minus 4 times a is 1 times c is 7. So I get 9 minus 28, which gives me a -19. Okay, so -19 is negative, of course. So if you look back at this formula, this is going to kind of help us make sense of how we answer the discriminant questions. If there were a negative underneath the square root, the only possibility is that I would have imaginary numbers. So if this were an imaginary number under the square root, my whole overall thing would be a complex number, because I have a mix of real and imaginary numbers. Because this part would still be real, but this part would be imaginary. So I have complex numbers, and I have 2 of them, because I have the plus version and the minus version. So I would have 2 complex answers, and I've got all the options there in the multiple choice. That would be letter F. 15, same problem, different equation. We've got x squared equals 4x minus 4. Now, you can go in either direction. You can move this stuff to the left, or you can move this term to the right. Whichever way you go, you need to get it in standard form first, just like I said with number 13. So I am going to subtract the 4x, then I'm going to add the 4, leaving me with 0 on the right-hand side. And I'm going to do this discriminant formula again, because 15 is the same question. So b squared, it's negative 4 squared, minus 4 times a is 1 times c is 4. So if I square negative 4, I get 16, and then 4 times 4 is also 16. So that's a 0. So if I get a 0 under the square root, let me flip back to the original formula. If this thing is just a 0, then all I have is negative b over 2a, just one answer. It's like plus 0 and minus 0 doesn't give me two different answers. So we only have one answer, just one. And because it's b over 2a, it's going to be like a nice, neat, pretty, rational answer. Okay, so same options that were given here. This would be letter C. Now we've got two other options that we can talk about right here. If under the square root, because notice with like number 14, we still have two irrational or two rational. So our other options, underneath the square root, say I have a perfect square, like it's 36, 25, something like that. The number underneath the square root would come out as a nice clean number, which means that these would be nice, neat, rational answers. So if this is a perfect square, I would get two rational answers. If this were positive, a normal positive number, but not a perfect square, then I wouldn't be able to simplify the square root, and so they would be irrational numbers, but I would still have two of them because I have the plus or minus. All right, so those are your other two options. We saw getting a negative number and getting 0, but there are two other numbers. You've got a great chart on that in your chapter 4 notes about how the discriminant works. Okay, 16, what's the vertex? Now, if we look at this one, this is in vertex form. I see people all the time doing way too much work for this type of problem. We saw this, I think, on just this second problem, like 10 minutes ago. The vertex, you do the opposite of this and then this. So remember, x lies. So you take a positive 3, but then the y value is a positive 6. So that would be J. Do not, with those ones, do any more work than you need to. That should be a pretty quick and easy answer. Okay, we actually saw, we might have seen this exact question, something very similar at the beginning. Okay, so what is the equation of the axis of symmetry? Let's start by getting the vertex. Remember, x lies, so negative 6 and then positive 1. We know the vertex is going to lie on the axis of symmetry, and the axis of symmetry will always be an x equals line. So x equals negative 6. So that is my axis of symmetry, letter B. Number 18, which quadratic function does these two things? All right, so let me show you. So for the vertex, let me write down vertex form. And you'll see it matches perfectly with the two equations that I've got right up above. So you can see these all have these same parts. We've got this leading term, then x minus h, and then plus a constant at the end. So we know what the vertex is. It's 2, 3. So let's start with that. So plug in the 2 for h. Plug in the 3 for k. That's my vertex. So automatically you can eliminate two of your answers. H and j don't make any sense here. And then it passes through the point 1, 0. So if I give you something like that, if I give you a point 1, 0, 1 is a sample x value, 0 is a sample y value. So what I can do is I can plug in 1 for x and 0 for y, and then the only thing I need to solve for is a. Okay, so in place of y, I'm going to plug 0. Here's my a. That's what I'm going to solve for. Plug in 1 for x, and then fill in the rest of the equation. Okay, so I'm going to simplify this up. So order of operations tells me to start inside the parentheses. 1 minus 2 is a negative 1. Negative 1 squared just comes out to be 1. So 1a plus 3 equals 0. So I can subtract 3 from both sides, and I will end up with a equals negative 3. So if I'm looking at my options, the only one that has a negative 3 out front, let me rewrite this equation. There we go. So now I plug this in for A in my formula. So this is the equation I come up with, and that's letter G. Okay, 19. Which one is graphed at the right? All right, let's figure this out. So let's start with the vertex. The vertex is the high point right here. The vertex is negative 1, positive 4. Okay, so negative 1, positive 4 means I should have a plus 1 and then a plus 4. Okay, so it's either A or B. Remember, x lies. So the fact that this is a negative 1 means I should have a plus 1 inside the parentheses. So these two are out. All right, so it's going to be one of these two. And now we've got something really easy because it's either positive on the outside or negative on the outside. Now the value on the outside tells me whether my graph is right side up or upside down. Positive would mean it was right side up. Negative would mean it was upside down. So this is the negative version. This would be letter B. Okay, number 20, our last normal question here. X minus 4 times x plus 2. We want it to be less than or equal to 0. So we're going to start by setting these two pieces equal to 0. That's going to help us set up our little sign chart. We're going to do the algebraic method. So add 4 to both sides, and I get x equals 4. Subtract 2 from both sides, and I get negative 2. Okay, so I can set up a little sign chart here. This represents my number line. I'm going to put the negative 2 right here, and I'm going to put the 4 right here. Make sure they're in numerical order, the same order that they would appear in on a number line. Otherwise, this won't make much sense. So what I just did is I split up my number line into 3 different regions. I know that if I plug in negative 2 into this inequality, it comes out true because it's equal to 0. I know if I plug in 4, it'll come out true because that'll make it equal to 0. I'm trying to figure out what range of numbers will make this inequality true. What range of x's, if I plugged it in for x, would make this less than or equal to 0? So since I've just split up my number line into 3 different regions, I'm going to plug in some test values. Okay, so let's test something like negative 10. Okay, so if I plug in negative 10, if I plug it in here, I get negative 14. If I plug it in here, I get negative 8. Negative 14 times negative 8 will come up positive. Something positive is not less than 0. So if I plug in something here, it makes my inequality false. Let's try something here, something like 0. If I plug 0 in here, 0 minus 4 is negative 4. 0 plus 2 is 2. Negative 4 times 2 is negative 8, which is in fact less than or equal to 0. So this test value makes the inequality true. Then something bigger than 4, like 5 or 100 or anything you want. 5 minus 4 is 1. 5 plus 2 is 7. 1 times 7 is not less than 0. So that test value made the inequality false. So what I want for my answer is just the region that made my inequality true. So I'm going to use a 3-piece inequality to set that up. So I'm going to use negative 2 is less than or equal to x, which is less than or equal to 4. That's how I set up the 3-piece inequalities. I use the or equal to's because my original inequality had the or equal to's. Otherwise, I wouldn't have them. All right, and so that is letter G. All right, let's see if I can squeeze the bonus on here. Find the x-intercepts and y-intercepts of this graph. Okay. Might have to squeeze some things in here. Let's start with the y-intercept. Remember, for y-intercepts, you set x equal to 0 and solve for y. Okay, so start inside the parentheses. So inside the parentheses, I get a negative 4. When I square it, I get 16. Okay, so 4 squared is 16. Then times 2 is 32. So 32 minus 18. So when I take 32 and I subtract 18, I get 14. So my y-intercept is 14. I've got that. And then for my x-intercepts, I set y equal to 0 and solve. So 0 equals the rest of the equation. Sorry, I'm trying to save paper and squeeze this in here. So I'm going to start by adding 18 to both sides. So I'll have 18 equals 2 times this quantity right here. Then I'm going to divide both sides by 2. So divide by 2 and this will cancel. 18 divided by 2 leaves me with 9. Okay, last thing, I'm going to square root both sides. When I square root the 9, remember I get plus or minus 3. When I square root this, I just have the x minus 4. So add 4, just about done here. So I get 4 plus or minus 3. So 4 plus 3 is 7. 4 minus 3 is 1. Those are my two x values. All right, definitely a challenging bonus there. Okay, so that is the end of chapter 4. Just one more to go.